dividing. Always reduce the fraction and simplify completely. So remember, we want to, whenever we have a radical like this, it really is radical 12 over radical 16. The first thing we do is bust it up. We write it as two separate radicals. And then we want to simplify wherever possible. So the bottom number is a perfect square. So that's just going to simplify to 4. Right? Square root of 16 is 4. Then the 12 is going to break up into radical 4, radical 3. Right? 4 is the perfect square that goes into it. So, square root of 4 is 2, radical 3. That looks like it's our answer. Okay? Because radical can't be simplified anymore. But, if I just gave you the fraction right here, 2 over 4, that reduces, doesn't it?
Yeah.
To 1/2. So, our real answer is radical 3 over 2. Or if you want to put the 1 there, you can. You don't have to. There's your 1/2. Okay, now this one at first doesn't look as, easy as it really is going to end up being. Before I even break this up, if I gave you just the fraction, 3 over 75, that can be simplified. Because how many quarters make 75 cents? 3. 3 quarters make 75 cents. So this really reduces. If you divide by 3 and divide by 3, this reduces to 1 over 25. Right? You always want to try to deal with your radicals as fractions first. Just look at them as numbers and see if they'll simplify. So this actually simplifies to radical 1 over 25, which if we bust it up is radical 1 over radical 25. And 1 and 25 are both perfect squares. So square root of 1 is 1, square root of 25 is 5, and we're done. Now, if you didn't recognize that that's 75, 3 over 75 reduced, this would be a much harder problem. Because you'd have to break the 75 up into 3 times 25, bring the 5 out, you'd have a radical 3 on the bottom, and then you'd have to rationalize it, which we're going to talk about later. But this one actually requires no rationalization, which is more work, if you look at reducing the fraction first. Again here, radical 64 over radical 4. Radicals can reduce just the same way fractions can reduce. So if I just gave you 64 divided by 4 as a fraction, what would it be? How many times is 4 going to 64? 16 times. So this is really just the number 16. So therefore, radical 4 goes into radical 64, radical 16 times. And that is simply just 4. That's it. So if you reduce these fractions in the radicals first, life is much simpler. Now, let's get into the mathematical requirement of not having radicals in the bottom. So, when we have this issue, we know that radical 2 times radical 2 is simply just 2, right? A radical times itself makes the radical disappear. Well, if we don't want a radical in the bottom, the easiest way is to multiply by that radical. So if I multiply by radical 2 right here, I'm going to get 2 right there, right? Radical 2 times radical 2 is 2. But if I multiply on the bottom by that, I also multiply the top, and that gives me that. 3 radical 2 over 2. And no, the 2's can't reduce. The 2 on top is under the radical. The 2 on top on the bottom is not. The 2 on top is an inside number, the 2 on bottom is an outside number. This is really the fraction 3 halves. 3 halves times, you could also write it like this, 3 halves times radical 2. It can be written like that. That's why you can't cancel the 2's. That 2 is actually part of the coefficient. So, again, very simply, and it gets more complicated after this, but if I want to get rid of radical 6, I just simply multiply by radical 6. And then I do that on the top also. On the bottom, that's just going to simply give me 6. And on the top, I have 5 radical 6. And I'm done. Remember, 4 and radical 10, we cannot reduce that because they're both not under radicals. So don't be thinking, oh, I can do that 2 over radical 5. Can't do that. If it was radical 4 over radical 10, I could do that. But not like this. So I simply want to multiply by radical 10. Top and bottom. On the bottom, that gives me just simply 10. The radical is gone. And on the top, 4 radical 10. But this is one of those cases where I need to make sure I simplify. 4 over 10 are both even numbers, which means I can divide by 2. Which will give me 2 and 5 radical 10. So the 4/10 reduces to 2/5. So, apply the quotient rule, in other words, bust it up into 2 radicals, reduce it, look for any perfect squares, reduce, simplify, reduce, and if you have to, rationalize, and then reduce. So you're always looking to reduce, you're always looking to simplify. Okay? We're just going to do a couple of these. So first off, this is really radical 25 over radical 3. Now, I don't want to rationalize first. Simplify first. So the top simplifies just to 5. Now I'm going to multiply by radical 3 over radical 3. Because if I did it before, I'd end up with radical 75, and that's just more work to reduce. Always reduce when you can. Now I rationalize. And I end up with 5 radical 3 over simply 3. And since the 5 and 3 don't reduce, I'm done. The next one. Again, I could rationalize now, but I get radical 16 on top. Why not break this down first? This is really 2 radical 5 over radical 3. Reduce first. Always reduce. Now, to get rid of that radical 3, I multiply by radical 3. Top and bottom. Inside times inside. 2 radical 15 over 3. And that's it. Now this one, again, reduce where you can. What number goes into 55 and 10? 5. So I can reduce this simply to radical 11 over radical 2. Much smaller numbers to deal with. So now instead of rationalizing radical 10, I'm rationalizing radical 2. And that's simply radical 22 over 2. 22 does not reduce. 4, 9, and 16, no, we only do it evenly. You can't simplify the 2 into the 22 because one's an inside number, one's an outside number. Okay, this one, there's really not much to do here. Just straight up rationalize it. That's going to give me 9 radical 3 over 3. But the then last step, 9 divided by 3 is simply 3. I don't know why I'm doing anything else. Oh, yeah. So the 9 goes into 3, and then we're left with the radical 3 inside. We're going to do 2 more. Not 3 more. All right, so this one, bigger numbers, okay, but there's actually a number that goes into both of those. 6 does, no, 6 doesn't. 7 doesn't. 4 does, okay, but there's a bigger number that goes into both of them. And that's 14. You may not see it right off the bat. But 14 goes into both of these. 2 times and 3 times. Now, you could have reduced by 4 at first, and you gotten 7, 7 over, well, 42 is about that. 42 is reduced by, no, you could have reduced by 7 first, sorry. So you could have reduced by 7 first, and gotten 4 over 6. And then you probably would say, oh, they're both even, 2 over 3. So if you don't see 14 right at the bat, okay, divide by what you can, reduce by what you can. But 2/3. And then we just simply rationalize the radical 3, which gives me radical 6 on top and 3 on the bottom. And remember, do not say 3 goes into 6. Because one's an inside number, one's an outside number. Same thing here. Reduce first. 6 goes into this 6 times and into this 5 times. Much smaller numbers to rationalize. Radical 5, radical 5, gives me radical 30 over 5. And nothing goes into 30. 4, 9, 16, you're not going to 30 either way. Now this one is not as messy as it looks. If I just gave you the fraction 5 over 6 times fraction 2 over 5, yeah, you could do 10 over 30. But look what happens. 5's cancel, right? 2 cancels here. This is really just radical 1, which is just 1. Do that. Over radical 3. So, square root of 1 is just simply 1 over radical 3. And then you rationalize it. So you end up with radical 3 over 3. And you're done. So simplifying first is the key. Reducing wherever you can.